I don't know about others, but this session is for me. This will be a panel discussion on establishing a new dialysis unit. So the context is I want to start a new dialysis unit inside a hospital and I need to start from zero. So I need advice on choosing the area, the machines, water treatment plant, distribution system, other equipment, personnel, how to operate it, and documentary and regulatory compliance. To discuss this, we have three eminent panelists. I have carefully chosen them across 3 generations of nephrologists. Dr. Mohan Rajapurkar, we are already introduced to. Sir, please come to the stage. Dr. Valentine Lobo. And Dr. Snehal Gaikwad. She is nephrologist at Imperial Hospital, Pimpri Chinchwad. I've come to them because all of them are expert in establishing a center, managing it, and making it a high-end, a high-quality center. So, directly coming to the point, first, Dr. Snehal Gaikwad, is it really worth having our own unit, or should I let a technician have it and I just get attached to it, or let hospital do it and I'll just mind my own medical business?
Thank you, Dr. Vipul, and the entire team for having me here. I am yet to reach that stage of expert and managing the unit, but it's the first and most prudent question which comes to everyone's mind as soon as we cross the line and become a consultant. So it's definitely worthwhile to have your own unit, personally rewarding as well, professionally, ethically, everywhere. Because we would have complete control over the quality standards without having any commercial interest in it from the corporate or any other partnership we go through. So it's more of patient-centric approach wherein we can integrate the entire nephrology practice in terms of the diet support, the medications, the dialysis prescription can be tailored to the patients appropriately and also have a good quality check on it. So it is definitely worthwhile to have your own unit. It comes with its own challenges itself, that we have to comply with many of the regulatory, take many of the approvals, and need to keep a check on the staff, arrange their shifts and all, keep an inventory, go through the myriad of tests for it. So if you're able to hire a competent help to oversee this procedure, then it's definitely worthwhile having your center. This is all the professional part of it. Even the finances play a big role. So for a small center with say 6 to 8 machines, an average cost in Pune to set up a center would somewhere be around 70 to 75 lakhs. With an monthly expenditure tuning up to 4 to 5 lakhs, which for the staff salaries, consumables, and all the running cost, including the AMCs. The revenue potential somewhere would be 6 to 8 lakhs, given if we are able to run 3 shifts at 75% capacity, so it would somewhere tune between 7 to 9 lakhs. So a break-even can be easily achieved within 2 to 3 years, and it's also profitable for the nephrologist per se. So this was your last part actually, whether we should have an individual own center, or it should be a partnership with the hospital, or it can be just that we oversee as a medical director. Also, there is an option to pair up with a existing dialysis unit, chain, like Nephroplus, Apex, or ASCAL, Universal Dialysis Center and all. So I personally feel owning a center would be better if, because of the practice constraint or family obligations or whatever, like in my case, it could be a partnership with the hospital itself, where we will have our own say on the quality control and all, and also keep a check on the pricing of the corporate. So that is much better.
I can sense a kind of anxiety with Snehal, and that's why the slides are quite busy. But those are strategically designed for you to have a ready reckoner when we provide this PPT to you. Sir.
One question that you had asked, there was some technician's unit. That's a complete no-no in my opinion. That's a complete no-no. The unit should be completely under care of a nephrologist. Now, who owns it is a different thing. A technician may put the money, but its running, its control has to be nephrologist. Just a technician's unit is no. And just get an attachment to sign off for getting a reimbursement is a crime.
Yes, sir.
I think your question is addressing the wrong person. You should ask the spouse whether it is worthwhile running the dialysis unit, number one. And number two, I think the second part is that it is like so many people come and tell me that, no, why do you want, we will take over your unit, you won't have any problems. Then I said, what's the fun in running a dialysis unit? I'll hand it over to somebody and you will do all the job. But when will I learn? Unless you have your own dialysis unit where you are controlling, that's the time you will actually learn.
I set up a dialysis unit way back in '79, and my spouse has not complained even once.
So he was specifically, sir was mentioning me because being a lady and taking care of the house, it becomes a little difficult. You know?
I have feedbacks from the other side, so I know. So you're
Also, excuse me for the slides. Actually, I had targeted it for the students
yes,
to have a ready reckoner.
we are going to give them PPTs. For Dr. Rajapurkar, how many machines should I have in the unit? Minimum number of machines to make it economically viable, and can I expand the unit later, and what provisions do I need to have the expansion?
Obviously, your number of machines will depend on what is the space you have available. So, each machine would need at least about 100 square feet. If you want to have, see, the point is the space is needed not only for the bed or the chair, the dialysis machine itself, and one attendant sitting there. And in an emergency, you should be able to wheel the cart in all around the bed, and you should have spare plugs and things like that. This is extremely well described in the setting about the haemodialysis unit, which was first written for the Indian Society of Nephrology in 2010 and was completely revised in 2020. In fact, one of the colleagues, Dr. Gomati, was with us in writing that chapter on setting up of the dialysis unit. So the other important point is, if you are going to provide good dialysis, you should need to double your machines in 3 years' time. If that doesn't happen, then you're doing something bad. So because the patients will do well, you'll get more load and you'll need to expand. And of course, there's a limit to the amount of expansion. For an individual person, I would think if you're running, say, 10 machines in 2.5 shifts, that is taxing your physical and mental capacity to the maximum, apart from the other nephrology practice that you're going to do. At that point of time, you need to recruit one more or add more personnel to it. Economic viability, we have already heard, and I don't think there's an unviable machine. If that was the case, then so many technicians wouldn't have started on every street corner giving nonsensical dialysis. Provisions to be made for expansion, you'll have to, when you're, as you said, you're starting from zero, you can consider where you will expand, and you're building structural capacity. If you, adequate load-bearing capacity in the foundation needs to be done right at the beginning. If you start doing it next time, then you can't augment a foundation. So therefore, you should do it right at the beginning. And for all these support services that you require, water, so I always built in that extra capacity for water right at the beginning, because if you want to make a new one, then it costs more.
So we can aim for big and start modest and then expand. So we were talking about area. So what is the optimum area needed for each HD station, and how much more area will I need for non-clinical operations, and what should I choose, a bed or a chair?
Yeah, so I think the first part Dr. Rajapurka answered, and this was discussed discussed, and then the final guideline was put in the ISN guidelines. There's no better source than to go there. The key, as I said, is that in the event of an arrest, one should be able to get all round there and perform CPR. How much more for area for non-clinical? You've listed out the water treatment plant. Yeah, I mean, I would like to have it, if I had a choice, as close to my dialysis unit as possible, because if it's tucked away somewhere else, then you would need to have a dedicated technician or would have to go yourself every day to visit it. So I've seen hospitals where the water treatment plant is on a service floor along with the air conditioning, the UPS and other things, and it's often in a locked room. So that's not a water treatment plant. Depends, the size that of the room you will require will depend on the capacity of the plant. And I think you have a question further about the capacity, what capacity of storage tank, etc., which will come. So that would answer the question. It has to be able to accommodate the plant. It has to be able to accommodate the storage tank, if there is a storage tank, and it has to have space again for moving in equipment that is required for servicing, for preventive maintenance, and for other things. Though all that space has to be taken into account when planning the area for water. Preparation of concentrates. So we would advise that the technical area and the area for preparation of concentrates could be combined. That is what we do. So those areas would need to have, in addition to electrical supply, they would have to have a source of the treated water and also drainage pipes in that region. Most preparation of concentrates today is either using dry bicarbonate or mechanically stirred, fortunately, as compared to the time when 10-liter cans were used to mix concentrates, and there was invariably a bicarbonate powder at the bottom which caused its own problem. So the technical area and the preparation would have to accommodate space to have a mixer capable of mixing anything from 100 liters to 200 liters of dialyzed concentrates at a time. Reuse areas should be separate, and the reuse area should have an area for wet storage. We try to minimize the spillages of chemicals and so on by having racks and then placing each dialyzer and tubings in closed sandwich boxes, which are able to preserve the area clean and dry. Dry storage would include your dialyzers, your tubing sets, your fistular needles, and various other things, whereas you would have to have a wet storage area for concentrates and for all the chemicals that are required for machine disinfection, for machine surface cleaning, for regeneration of your deionizer system if it is there, and so on. And the nursing station, of course, should be centrally placed. A C-shaped configuration of the dialysis area where the nursing station, from the nursing station, all the beds are visible would be a nice system. We were able to design it in one of our units, not in the other, because of constraints of space. What should one choose, bed or chair? I haven't used chairs. The key, I think, would be is that if you're going to use a chair, you can put in more space, you can put in more units within the same area, but you should still be able to approach the patient in an emergency and work in a way that the emergency is tackled safely and with an optimal result. A lot of patients actually prefer lying down. That's at least our patients. So even where we do have Fowler beds which can be completely propped up, a lot of patients prefer to lie down during dialysis. It's an individual thing. I believe there are classes of patients who prefer a chair, who prefer to sit up, who would prefer to be watching TV, listening to podcasts, working on their laptops. So chairs but Fowler beds with an overbed table can also take care of it. There's also the question of cost. An ICU bed of the type that you need for dialysis, that's the most simple one, is about 25,000 rupees. A chair is 85,000 rupees.
So,
chemical storage and where your water treatment system is there. If you're going to use resins and you're going to use acid and alkali for regeneration, spillage of acid and alkali will make a mess of your floor.
Yes.
It always corrodes and corrodes structurally. So therefore, it is a better, if you can, today you should have an electric DI that takes away the acid and alkali spill.
Yes.
But if you have it, then it must have a separate clear-cut drainage, and the floor needs to be done with FRP-proof tiles, so that and there are no leaks between. So you need to do waterproofing with the same material. Otherwise, you are definitely going to destroy the floor.
Yes.
Weighing beds would be ideal, but in an MHD unit, we expect the large majority of patients to be able to walk in or at least on wheelchairs, and there are good quality weighing scales today onto which a wheelchair can go, and then you can measure the weight of the empty wheelchair. Weighing beds, we put them into the acute care unit so that we can actually, our patients getting SLED and CRRT, we can weigh them daily. But they are expensive, 1.6 lakhs for a weighing bed of a good quality, and at the end of that service of when that weighing scale, that electronic weighing scale starts giving problem, service is not great. ICU should have some weighing beds.
Well, I tried to make a weighing bed myself by putting 4 sensors under the bed and then connecting them through a sensor and a IC to continuously read out the weight change. But what usually happens is that the patient gets slight chill, 2 blankets or 3 blankets are put and nobody remembers what that, and the fellow automatically increases or decreases the ultrafiltration. So ultimately I gave up for routine work. In an ICU, if you are able to control what you put on the bed, the patient asks for a book to read or gets his laptop after he's weighed, those half to 1 kilo difference does make a ultimate difference in what you achieve.
Definitely.
We'll now come to water treatment plant and take audience questions after the water treatment discussion. So what factors should I consider while designing the water treatment plant, and what should be the pre-RO part of the plant?
Yeah.
And what should be the optimum maintenance of that?
The first thing you must ask yourself is how much water do you need treated. Now, each machine that you have or you're planning uses at least 30 ml per minute, which means you require 30 liters at least. So I would add about 25% more to that, so about 45 liters per hour. And then I'm saying that every day, if you take out the time for sterilization, time for cleaning, and time for the time when it is going to remain idle, you calculate for 16 to 18 hours a day, and then double that with your capacity. Why double it? Because as and when there is a maintenance problem or your machine, water treatment system needs some maintenance, then your system should not go down and your dialysis should continue. So that is the quantum of water you require. So based on that, you design your... Now, I think you need to know, then the next thing you need to know is what is the worst quality of raw water that you are going to get to treat. Now, whether it is a deep well, if you're a deep well, say something like I have in Nadia, 400 feet deep well, which is the only source, then I really don't expect any chloramines to come there. Even from the surface fertilizers, they don't go beyond 150 with 300 feet. So the earth is a good filter by itself. But then at that level, you require a sand filter to take away particles. You may avoid using a carbon filter in my unit because that is the only source of water I get. And even at the highest time of summer, my TDS in the incoming water is 400. So I need much better mineral removal rather than chloramines. But if you don't know, you're saying then you need two carbon filters in tandem, and then you need to monitor them to see whether they are exhausted. Then you replace the unit with a new carbon filter and take the second polisher out and put new one, and that way you keep rotating. Deionizers, it is good idea if you're going to have, and I've used deionizers for 40 years plus. It's a good idea to not only have a cation resin and anion resin, add a mixed bed to it. That way you will be able to get correct. So, regeneration system, conductivity meter at each place, somebody reading and writing it down, that is required. Softener, if it is a situation like mine, where we only have that, we had added a softener before, in the previous unit, we added a softener before the 3-column DI. Because that way my resins regeneration requirement goes down. Not so much as it is absolutely needed to get rid of it. In the present system, what we have done is we have got 2 ROs in series followed by electric DI. So you polish off the remaining with an electric DI and you completely obviate the need for acid and alkali there. So pre-treatment will depend again on, so you need a stand, and then you can finally add a membrane filter. Usually 0.22 micron membrane filter is good enough. And each of these, you need to set up either timing and pressure drops to tell you when it's time to backwash it.
So what will be the sequence of pre-treatment? Carbon softener or softener to carbon?
Softener before carbon.
Softener before carbon.
If you place your carbon before the softener, you are removing the chlorine, and softener resins will then tend to grow bacteria. So keep the chlorine until you can afford to get rid of it. You don't want the chlorine to reach the RO membranes.
That membrane filter after the carbon helps to sort of prevent carbon fines going to your RO membrane.
So to Dr. Lobo, what lies between pre-treatment and RO?
Dr. Rajapurkar just answered that.
Yes.
So it is filters 5 micron and 1 micron in series to prevent the carbon fines from blocking the RO membrane.
And what should be
And
the capacity
those we change. So the capacity of the RO pump, it's a centrifugal stainless steel pump. It should be capable of developing pressure of up to 15 kg per centimeter squared. The optimum RO performance, usually membranes require about 10 kg per square centimeter for optimal operation. If you cannot deliver that, then you're not going to achieve that 90% TDS reduction from the incoming stream of water. So one would need an RO capacity, an RO pump that would develop at least 15 kg so that it would go beyond. Most stainless steel housings are limited to a breaking strength of 15, so you don't want to go beyond that pressure additionally. And there are pressure switches placed, a low pressure switch before the pump, a high pressure switch after the membranes, which will ensure that the pump would cut off in such situations.
So we can discuss about RO and its maintenance.
Yeah. So how to choose the membrane? Can you show the, yeah. So these are some of the membranes which are freely available. What you have is that first one which says 40-40 hydronautics. It is 4 inches in diameter and 40 inches in length. So for some reason, engineering terminology still uses the British foot-pound system instead of the metric system. You can see that the other ones after that, most of them operate ROs. The optimal performance is somewhere between 37 and 50 degrees. When you go beyond that, you can get damage, though there are now heat-stable membranes available. The permeate flow is provided by the manufacturer. The percentage salt rejection, they all claim 99. If you get 95%, you would. And therefore, you need to have TDS or conductivity meters before the RO membranes and after the RO membrane as well, so that you could note that this reduction of the TDS is actually about 90%. you can see the operating pressure, 600 pounds per square inch over there. That is about 15 kg per square centimeter. The maximum chlorine concentration that is permitted is less than 0.1. If you have a chlorine concentration more than 0.1, it is going to damage the ROs. The membrane surface area of the Hydronautics and Lentex is about 85 square feet, and now Hydronautics has come up with what they call the CPA3, which is 400 square feet, which is a much larger membrane, so it has a much higher output. And that is an 80-40 membrane, so it's 8 inches in diameter. Next, yeah. So the pH range at which the RO membranes function, the feed water's turbidity in normalized turbidity units. So we've added a turbidity meter pre-RO as well, so that we know that our sand filters have removed enough particulate matter. The cell density index, we could put that in, we don't have it as yet. What is the maximum feed flow? And what you can see last of all is the key, that this is what RO membranes will do. The permeate is usually about 20% to 25%. So the reject concentrate to permeate flow is about 5:1. So when an RO claims that, oh, you're going to get 40%, you're going to get 50%, that's generally not true. It's done by feeding the concentrate of the first membrane to the second membrane as a feed, and that's how the capacity will be increased. But an actual RO membrane will usually reject 75 to 80%, 70 to 80% of the water fed to it. So choosing the membrane, look at what is the operating capacity, what is the area, and therefore the output that you are getting. What is the feed flow required? Is the raw water pump going to give that feed? And what is the turbidity of your water, and plan the pre-treatment accordingly when choosing the membranes. Yeah.
Develop by only membranes and get it
Made. Yeah. Yeah. That also is done. So this is about the monitoring that you asked. So you can have a conductivity meter. As I said, you can have a meter that displays conductivity and TDS. Now Asteronext is giving us multiple probes and multiple displays. So we get, on our system, we get pH, we get chlorine, we get continuous readouts of pH, chlorine, turbidity, and TDS. So we are able to show this both pre and post. If you are using a deionizer, then because the deionizers achieve a higher mineralogical purity, especially when they are used after the RO, conductivity means, as you can see, as the values go lower and lower down, the least count of the instrument is decreasing. So something that reads like that, 0.00, may actually have a value that is somewhere like 0.05 or 0.06. So using a resistivity meter in such a situation, where it's measured in mega ohms rather than microsiemens, becomes more accurate for water of very low mineralogical content. So water resistivity, 1 mega ohm corresponds to 1 microsiemen, and so on. And the maximum that you can reach is 18.25, or the 0.005 is what you can reach as a maximum resistivity of water. If the monitor starts reading more than 18.3 mega ohms, it needs to be taken out and serviced. Next. Yeah. So how to interpret? Dr. Rajapurga talked about pressures. What we have is flow meters, pressure meters, and TDS meters on our control panel. And this is what you would find. Early scaling, the inlet pressure is increased, the reject pressure is increased, the TDS reject would be normal in such a situation, the differential pressure is normal. When you have fouling or heavy scaling, the differential pressure is increased because there is an increase in the inlet pressure more than the increase in the reject pressure, and the percentage TDS and the flow both are decreased. If there is a membrane damage, then the pressures are all decreased because there is a free flow through a membrane which is damaged. The permeate flow is increased, but the TDS reject is very low, or in other words, there is a very high conductivity or no change in the inlet conductivity and the outlet conductivity of the RO. And finally, there can be a mixing of the concentrate and permeate stream simply because the stainless steel housings are built by the vendor most often, and the O-rings that come are standard. So if the groove that is made for the O-ring is not perfectly cut, then that O-ring slips out of the groove and your two streams mix. In such a situation, you have a mild increase in the outlet conductivity with all other parameters being normal. look for the O-ring. The O-ring will usually have slipped out of its side. And you need to replace the O-ring and actually cut the groove deeper. So we faced this problem twice. Yeah. So this is what membranes look like. Those are brand new polyamide Dow membranes, and this is a silica scale on a membrane which I had to replace after about 2 years, after which we introduced anti-scalant dosing pumps, because this was a component that was not checked, that silica is not usually checked when the water analysis is done. So you can take care of hardness with a softener, but you cannot take care of, if there is an amount of silica that's coming in the water, then you may need to add anti-scalant dosing pumps in such situation. And it's automated. So it's fed, the pump's supply comes from the main control panel. So that as soon as the RO switches on, the anti-scalant also switches. Yeah, okay. I just wanted to put the last, that all membrane cleaning. So when does we clean membranes? When there is a 10 to 15% drop in the permeate, a 10 to 15% increase in the TDS, and a pressure differential of more than 1 kg along with a high conductivity, but with the caveat that membrane cleaning is only a sort of polishing or buys you time. Preventive maintenance is the key. No RO membranes can be completely cleaned by any method because of the high surface area and the infinite number of pores which are available for scale and crystals to form. So you can never completely clean them. A time will come when that membrane would have to be replaced.
So this is a divided question. So after RO, should I have storage tank? And if yes, then what will be the make of it, and what will be the capacity, design, and precautions to be taken? Does having a tank add some additional parts to the treatment plan? And for Dr. Lobo, should I have deionizer in the system? What are the advantages of it? How to maintain it? And a word about electro-deionizer, which sir alluded to initially.
Well, storage tank capacity is the same way to calculate as I told you at the beginning. So you must have about 10% extra place in the. It has to be, because it's post-treatment, it should be stainless steel. I personally prefer it jacketed. Now, if you're working in India or in a hot climate, often the ambient temperatures can be 40, 45, and with nowadays it's in some places in Rajasthan touch up to 50 ambient temperature. Even in shade, the temperature is somewhere around 38, 39. So almost every patient used to get fever in my old unit many years ago. So we used to, the inlet pipe we would extend, make it around from the pipe to the machine, and put it in an ice cold water. Now, the machines have heaters. They don't have a refrigerating system. So therefore your water is best kept at around 35. So what I have done is I jacketed the thing, and jacketed stainless steel jacket. The jacket itself does not be stainless steel, but it is glass wool covered so that you don't lose heat there. And you circulate the chill water reject from the air conditioning through the jacket to keep a temperature of about 35 in the tank all the time, 35 degrees centigrade. So it should be jacketed, to my mind. It works well because that the water can be then reused for this purpose. One has to make sure that both the inlet and outlet valves are kept open, because once what happened was the outlet valve somebody closed, so the water pressure in the jacket rose so much that it actually crushed the stainless steel tank. And to redo the whole tank, and it has to be stainless steel, should have a venting system with no return valve at the top. Your last drop of water should be able to be drained from a floor level drainage, and a system for either heat or chemical sterilization for injecting into it. When you are doing heat sterilization, I made a bad mistake when we did everything, and this time the last system, which I forgot to tell them to do stainless steel welding, because we added a heating element to the tank. What happened was, the first time we started doing heat sterilization, all the welded joints gave way and the whole dialysis unit was in water pool. And then, because many of those pipes were concealed, nobody would allow me to change that altogether. So we still got back to chemical sterilization of the loop.
So Lobo on deionizers.
So, yeah, you got the Indian Society of Nephrology guideline that for those units aiming for ultra pure, the electric deionizer, as was said, is required. The advantage Dr. Rajapur already alluded to, we have used the resin deionizers for the last 20 years. The problem, of course, is the hazard of acid, not just in spillage, but also of injury to technicians who may not be careful enough with wearing the correct protective equipment. You need to then provide them with plastic aprons, with goggles, etc. And still you could have accidents with strong caustic and acid. The electric deionizer takes care of that completely. It's also self-regenerating. All that happens is that the polarity of the plates is reversed and a stream of water flushes all the accumulated ions to drain. So that obviously has advantages. If you don't, mixed bed cation anion resins work extremely well in providing mineralogical purity. Deionizers were maligned for many years as being source of bacteria. It has never happened for the simple that if you use a strong enough acid and alkali, no bacteria grows. And if you do your regeneration regularly now we do it twice a week at least. And that's because we have good quality water. Otherwise, we might have to do it every day. I went to a unit, you were there with me on the occasion, where we found that the deionizer had not been regenerated for 7 months. And it was actually leaching magnesium into that, and patients were getting hypermagnesemia on dialysis.
But that's true of all these resin deionizers. Now, if the resin is saturated, the property is that whatever it has collected, it will release it into the... So you will actually make the water much worse.
Worse than what it was. That's exactly what happened. And we published that in Haemodialysis International.
What will be the cost of electrodeionizers?
Yeah, so the smallest capacity one is about 3.5 lakhs. It's expensive, and with it, if you're going to use an electrodeonizer, you must have a resistivity meter. Resistivity meters are about 30,000 rupees.
And does that change, does the capacity apply here, or it can take any capacity?
No, it obviously has a capacity depending on the size. The flow rate will depend on the capacity of the tube.
So
you have to choose the
Size based on your flow rates requirement.
we can take a few questions from the audience. Yes, sir.
I just wanted to make one practical point, is that the idea behind this discussion is that people might be wanting to set up their own units. But one thing from the environmental point of view, ROs are extremely wasteful, as you know, and an enormous amount of water gets wasted. So I just wanted to say that if you're setting up a unit, think of that, and you could reuse that water in many ways.
So the only correct answer to your thing is we need to develop sorbent cartridges where a used dialysate is reconverted to ultra pure by cartridge. Me and Lobo are trying but have miserably failed till date.
We've tried, we've not been able to so far.
We try to use that for the injected water to the toilets, but that also failed because it was clogging those systems. So we now use it for gardening, but I don't know what is.
All those things have been recommended, but you still are going to use large quantities of water in the day at the end. If you have 10 machines, then you're going to use 300 liters per hour. If you are running them for 2 shifts, you're going to be using 2,400 liters, which means that you start with 5,000 liters of water.
I keep on saying that increase your dialysate flow, there you are wasting more.
So there is Dr. Gopal Krishnan's group has done one paper where they decreased the dialysate flow and increased the dialysate temperature to 38 degrees and showed that the efficiency of dialysis could be maintained by that. And now they are looking at doing that in a multi-center study. But increasing dialysate temperature has its own problems.
One is the fever and second is vasodilatation.
vasodilatation and hypotension.
Whereas the other side is also true, that for an unstable patient you use a cooler dialyze
exactly.
it. That's there.
Any questions and comments from the audience?
Electrode you mentioned about that chlorine detection. Does
Yeah.
it detect chloramine also?
Yeah. So,
Or you extrapolate?
what? If you can measure the total chlorine, then that includes free chlorine and chloramines.
Okay.
So, you put a electrode which can measure total chlorine.
Yeah. So you take it as less than 0.1 and
Yeah.
you don't detect chloramine differently.
No. As I said, you can do it. We also did one more thing, that if what you can do is you can add a UV lamp.
Right.
One more UV lamp before the RO. UV light at the right wavelength, which is 180 nanometers, breaks down chlorines or converts them to chlorides.
Okay.
So we added that.
I know this may sound,
Yeah.
Capacity of the UV
UV,
lamp
of
was
course,
that.
it has to be.
this may sound little bouncer to students, but yes, this is required when you are when you pass out and start your dialysis center. So this will be available to you for as a ready reckoner. A word about UV you want to say? Like what wavelength should we use for what purpose?
So,
and
yeah, and also it's not only the wavelength. We put this in the ISN guideline on water treatment, that one is the wavelength is different. The second is that chloramines require an energy input in terms of joules per moles, of which is about 30 times that for chlorine. So if you are you may not be able to depend only on UV unless you can size your UV to deliver about, I think, 600 millijoules per second of radiant energy is what is the rating recommended. I can't remember it offhand. It's there in the guideline. But
And
that is what is required for chloramines. It then also takes care of your organochloric, oro, pesticides, fertilizers, and so on in such a situation.
and about the depth of RO.
Yeah, of
The
course.
depth
Yeah.
of
So the penetration of UV is limited to the energy falls off by the square of the distance. So you have to have a limited size and therefore a high capacity and a longer tube. That's for
Yeah.
endotoxin. We hear when he's talking about chlorine, it's not required.
So about the distribution system, what are various makes available, advantages and disadvantages of each? What are the methods of disinfection of the loop, and whether to conceal pipes or not? And if I want to set up my dialysis unit and ICU next door, so how do I give branch to the ICU?
So there are different makes available, and it could be an open loop system or a closed loop system. Mostly it is a closed loop system in practice, wherein it could be a direct feed, that is the treated RO water is delivered to the dialysis machines and circulated in the loop. There is no RO holding tank. The indirect feed system incorporates a holding tank in the system, so it's a direct and a indirect. We do not use the the single chain. There's no, so because if it is a single chain, then without a loop, then it becomes stagnant. When the system is, the unit is closed, it would be a stagnant system and therefore the biofilm formation. So it's always a loop, direct or indirect here in the loop system. So indirect helps because when the RO tank will serve a purpose wherein the machine is offline and we need to still sustain the unit, it helps. There are multiple advantages. There are others also, that the heat which helps with the heat sanitizable loop, also with the chemical sanitizable loop. So we'll come that forward.
About the makes.
People wanted about the material used for the water distribution system, which is three types are available. One is the stainless steel. Two grades are available, 304 and 316. Yes, sir, I was coming to that. Because some units have 304 also. Absolutely. So 316 is the grade of the stainless steel which is recommended, 316 and 316L, because it has molybdenum in 2 to 2.5%, which makes it more resistant, corrosion resistant, and is the recommended material to be used for the distribution system. Then we also have the cross-link polyethylene, that's PEX, which is also widely available, though less useful. And we do have PVDX, which is, I don't think so much of the units use here in Pune. It's so in stainless steel, the most useful advantage, it's a low biofilm formation and has an excellent, allows heat disinfection, stability in terms, and durability. That's it's up to 15-20 years also it can be sustained. And it is most importantly, we need to keep in mind about the compatibility with the disinfection, the material compatibility with the disinfectant way which we are going forward. So for stainless steel, it tolerates heat. It is excellent results with renal citric acid, but it is less tolerant to the bleach, that is sodium hypochlorite. So there is a risk of corrosion when you use hypochlorite. For PEX, it is poorly tolerates the bleach, can withstand temperature up to 60 to 65, not more than 85. For PVDX is the best, what is available in the flexible piping. It can tolerate, it is resistant to bleach as well, but not much use here. So going forward.
So which one would you go for?
I would go for stainless steel 316.
Other panelists?
I'd use 316 stainless steel. The Gambro system, Gambro's ready-made water treatment system uses PEX. PEX is tolerant to heat, but not to UV light. And also, therefore, strong sunlight can damage it.
No, needs covering.
So it needs covering.
Yes. So, what are the?
So this we talked about. The installation, the stainless steel is difficult to install in the unit and costs also. But then it is more durable and recommended by the guidelines. PEX is easy installation, least cost, but then the number of fittings also goes up, and the risk of stagnation, biofilm formation also goes up. And it is relatively tolerant to renalin or citric acid and heat in the lower degrees. But then, as sir said, we need to avoid exposure to sunlight. So jacketing is required.
So you want to say PVC is sasta hai but महंगा पड़ेगा. For the
Medical grade PVC is not recommended. So whether to conceal the pipes or not, as sir just said a couple of minutes ago, if the pipes are concealed, we are not able to visualize if there's any leak, and also the routine maintenance, the sampling ports and all, everything becomes difficult. It is always advisable in a dialysis unit that the pipes should be visible. They should be wall mounted, and the drainage slope should always be maintained. So though it is less aesthetic, but it is more practical and feasible. It's preferred.
You have to conceal it, you have to use a removable panels.
Yeah.
Removable panels are also good, but then people become complacent. Daily checking doesn't occur. So if it is a visible pipe, then daily we can inspect it. Also, it's easy access. Any leak can be addressed simultaneously. If there are concealed even chambers, like sir says, they are panel, then we are not able to identify those minor leaks, and it may then erode the surfaces inside.
Architects would want to conceal. Engineers and we would want not to conceal, and we have to be the referee over there. Yes. So one civil engineer told me the architect is the civil engineer's worst enemy, because aesthetics matter a lot, and we faced that where our architects designed our unit 20 years ago with a ledge wall into which they put the drain pipe. And the RO man said, I will not conceal my pipes. If you want them to be concealed in the wall, find a different vendor. So they weren't concealed. And we regretted that, because some years later, it leaked and that ledge wall had to be broken and a new drain line installed.
You remember we visited one good center run by a dialysis company, dialyzer making company, and they had everything concealed. So when they had it, endotoxin, almost entire thing needed to be changed.
So that is.
Eventually that unit got closed.
It is difficult to identify the site, where it got leaked.
About the ICU branch.
Yes. While giving a branch to the ICU, it should be a part of the continuous loop. We use usually a branch with a loop incorporated, so that it should be separately returned to the main tank, RO tank. And it should be of the same material which your entire system is, because people tend to do shortcuts. Now there's a stainless steel system now, whether to use a PEX, PVDX, it shouldn't be so. It should be of the same material and should incorporate a non-return valve, okay, so to avoid the backflow, and should have adequate sampling points for the water checking as well. So the drain gradient and all should be maintained. It should be daily visible for inspection.
It will also depend on what is the geographic location of your ICU from your renal unit. If they are on the same flow just adjacent, well, engineering principles will allow you. If there are too many bends which are going to be introduced by giving that branch, then it may not be worthwhile. One, because of stagnation, and the second is because your your transfer pump may not have the capacity to deliver the flow and pressure that is required at the end of the line.
So sometimes it is better to have dedicated system for that.
Yeah. So when we put in here, we have 4 systems, one for each of them, simply because the configuration of the buildings didn't allow a pipe to be taken.
So coming to the patient station, what should be present at each station, and how to design that?
Yeah. So as you have shown, this is again ISN guideline. You have the HD machine, you have the bed. We have, because most units today will have multi-para monitors, so we do put on a stand on the wall on which one can mount the monitor. Otherwise, they would be put on the bedside cupboard, the locker. The bedside locker, the monitor would be placed over there, and it is easy that it would fall off and so on. We also provide the patient a bedside locker and an overbed table, so that if a patient does want to sit up and eat or work on his laptop, that is available to him. Of course, there has to be a water inlet. Electrical socket. So as I just said, if you have, in addition to the dialysis machine, you would probably have a cardiac monitor. You may have a syringe pump or an infusion pump running in some situations for patients, because they are getting either nutrition or some drugs. So you would have to have additional electrical sockets for that. So the ISN guideline therefore recommended that 5 to 6 is the minimum number of electrical sockets to be provided per bed. Medical gases should be available, oxygen, air and vacuum and suction if possible. And hospital safety guidelines say that your electrical lines and your oxygen line should be a minimum of 2 feet away from each other. And that's particularly important if these lines are going to be concealed in the wall. Then diagrams should be available showing where the electrical lines are and where the medical gases lines are. We once had a situation in one of the ICUs where a workman came to put in a sterilium stand on the wall and drilled into the oxygen line. So, because he just didn't know that it was concealed in the wall behind. So diagrams should then be available showing where concealed medical gases lines, electrical lines, etc. are. As far as the drainage system is concerned, Snail just talked about.
Just before that, what type of electric sockets our machines require?
Good. So you need, each and every socket should be have both 5 and 15 amps. Dialysis machines take 9 to 10 amps of power. So you need to have a 15 amp socket for a dialysis machine. And most other medical equipment, including ventilators, take about 500 milliamps of power. So a 5 amp socket is good enough for most. But I would, today, because you can get 5 and 15, I would have all my sockets as both 5 and 15.
Coming to the drainage system, we'll come to this diagram first maybe.
Yeah.
We had a brief discussion yesterday in the workstation.
I'll call you back. Yeah. So yeah, we did discuss some of this in the unit yesterday. So as I said, the point I made at that time was that the people working in the unit are most worried that that drain pipe will fall out of the drain line and that there will be water on the floor. So they would tend to push it in as far as possible. And as you can see, the horizontal pipe will have some level of spent dialysate. Now, if the drain pipe is dipped into that spent dialysate, when the machines are switched off, as I told most of the batches, you will have bacteria migrating back along the pipe and into the hydraulics of the machine. So there should be an air gap and where the drain line is connected to the drainage system, And so we install those capped spouts over there, so that the end of the pipe dips in, is held in place by the capped spout, and there is an air gap between where the dialysate is falling and where it is accumulating. So you would prevent contamination of your machine by that.
About buying machines, how should I decide on which machine to buy? Additional perks that I can bargain from the vendor, and what will be optimum maintenance of any machine, and what are the common breakdown and to avoid them?
Any machine that is manufactured and available in the market today can provide adequate dialysis, while if you know your machine and are able to deliver it. So you can buy any machine who gives you the best buy at that point of time. Of course, it must have bicarbonate buffer, preferably solid bicarbonate. All machines nowadays have volumetric UF, but this was written several years ago when machines did not really have true volumetric. The engineer should be within 8 hours of dialysis unit. A set of spares should be maintained within 8 hours of the dialysis unit. Price negotiation should include initial price and AMC cost for 5 years, including spares, and those spares. And a built-in clause of downtime and pro rata reduction in AMCs for delays should be negotiated right at the time of the beginning. Actually, Nadiad had nothing, so they said we'll keep it in Ahmedabad and all. I provided them space, gave them almirahs to put their spares. I would monitor them, it was under my custody. A full set of spares would be maintained, and they trained an engineering student within Nadiad to be looking after our machines. So our the information of a breakdown to the engineer coming to the hospital was less than 2 hours, and the spares were available in the hospital itself. So I negotiated it. At the beginning you can negotiate, afterward you just cannot negotiate. Then whatever they say you accept. While you are buying it, you are the boss. And most people will agree to this. What I did not do at that time was pro rata deduction, but what is that pro rata was not specified. So when it came to actual deduction, we achieved less deduction than what I would have otherwise. So then now you can build in per hour loss depending on the busyness of your dialysis unit. There's an economic way to calculate it. And so from the AMC you deduct that for every delay.
Quick primer about the machine maintenance and what can break down.
Okay, so we did talk a little bit about preventive maintenance yesterday, about the various programs of disinfection that are available, including the importance of anti-scalent, if you don't, especially of decalcification. So especially if you do not want to see this alarm frequently on the machine. So next slide, Vipul. The reason this arises could be because of this. So what you can see here at the bottom left-hand corner is the degassing filter of the Fresenius machine in a situation where somebody has not rinsed the machine, has switched it off with the conductivity in the operating range, and that calcium carbonate precipitate has formed in the degassing filter, and that is going to result in that flow alarm. So the sites which can get blocked with a calcium carbonate precipitate are the diasafe most commonly. We talked about how the diasafe is guaranteed normally to have a life of 3 months or 100 treatments, whichever occurs earlier. And you can lose your diasafe after the first treatment if it is allowed to, if precipitate of this sort is allowed to form. The second, on the right-hand upper corner, is the gear head of the machine. So all the pumps are geared pumps in the machine because they have to adapt the load, the motor to the load for different dialysate flow rates. Now, when your sieve filters and your degassing filters get partially blocked, the gear head would tend to heat up, and it would actually, what is done is, what you can see at the previous one, Vipul? Yeah. On the left-hand corner, what the technician will do is to increase the digital analog conversion digits, make the motor run faster, and overload the motor over a period of time. Next. And that is what eventually will happen. Here, Fresenius, for some reason, still uses brushed, carbon brushed motors. And over a period of time, this is what will happen when you use it. That carbon is continuously shaved due to the contact of the brush with the rotor of the motor, and it will accumulate over here, and eventually it will block the rotation, it will obstruct the rotation of the motor, in which case the base of that needs to be cleaned with a dry brush and those carbon fines removed. Also, over a period of time, these carbon brushes will be shaved down and will not make proper contact with the rotor, which leads to sparking, one. And secondly, a point of time comes when it is not delivering the necessary current to the rotor of the motor. At this point, the carbon brushes have to be changed. Now, initially, the company used to change the carbon brushes. Now they say we will change the motor, and they charge you 7,000 rupees for a new motor and take the old motor away with them. Whereas you can buy the carbon brushes for 40 rupees each and change that. So what we do, we buy carbon brushes in the radio market and replace them ourselves. When the company takes the motor away, it's what is done in the factory is often to replace the carbon brushes and resell that motor to you as a new motor. So we buy our own carbon brushes, we replace them, and we do not allow them. If they say, if you are going to charge us 7,000 for a new motor, then we are going to keep the old motor with us. So the machines, there are the 5008 machine, the Ultra Touch machines, the Nikisho machines do not use brushed motors. They use brushless motors, which have an almost indefinite life. In 23 years of using the Ultra Touch, we have never faced this problem. The other
I'm cutting your favorite part, but we have last year we had entire session on this inside the machine, so maybe we can refer to that.
Yeah, sure.
For the want of time, I'm cutting this. So what other equipment are required for the concentrate preparation, the weighing scale, patient weighing machine, and the crash cart?
So major ones you did outline there. Apart from the hemodialysis apparatus itself, you would require monitoring equipment, the parts required for maintenance of the RO water treatment plant itself, the clinical monitoring apparatus. The utility part would include the scales, weighing scales, the BP manometers, the thermometers, and all the sheets, clinical sheets, the logbooks and all. So many of them I have listed differently for each.
Yes.
So I know Vipul is running short of time, so please read it later.
Yeah. So how do we
for
prepare
part A and part B, all of us are aware that part A is the acid buffer and B is the bicarbonate buffer. It may be the part A is liquid concentrate, and the part B is available as a dry concentrate, that's buyback, or we can be manually made into the liquid concentrate. So use of buyback is convenient, and sterility is maintained. Manufacturer, it is factory standardized, so it has a good shelf life also, but the cost, it adds to the cost. Yeah, not much, but then adds to the cost. If you're running a small center with less than 5 machines, then it significantly adds to the cost. But if it's a large center, we can use it as well, because while preparing the manual concentrate, if the sterility is not maintained, the bicarbonate mixer is not well maintained, and timely discarding of the unused solution is not done, then it could lead to the growth of the bacteria and contamination of the water itself. So
can we use that bag for 2 dialysis sessions?
Not ideal, not advisable. So it's available in 2 strengths, 600 and 900. So depending on the length of the session, you may use a smaller bag per session.
So the 900 provides you 150 liters, and your normal one dialysis uses 30 liters. So there is a lot of waste.
So lots is wasted. Just as I said, the maintenance of the equipment is more important, and before starting the use, you have to inspect the tank. And as earlier sir said, that it should have a supply of RO and drainage itself, and should have a good ventilation. So after you have inspected the machine, then you add fill the tank with the RO and add the recommended dose of the the dry bicarbonate. And then it is constantly agitated to prepare a standardized solution. So after use also, it has to be thoroughly rinsed and dried off to prevent any precipitate formation on it. So it requires a weekly maintenance and daily checks.
So what regulatory approval I need before start of center, and does a nephrologist need a nephrologist? Dialysis unit needs a nephrologist.
Last part doesn't need an answer from sir.
Minimum regulatory approval, if it was needed, then how are so many dialysis technicians doing all kinds of nonsense all over the country? enough to say that we don't need nephrologists. We do the dialysis, why do we need? And the fault entirely is of the nephrologist of not going to the dialysis unit when they should have been going there. Does the dialysis unit nephrologist, I mean, what is the question? What question is that? Is what I would say. I will argue that it must become a statutory requirement for the nephrologist to definitely see all the patients. You're subjecting somebody to a life-saving treatment and you're yourself not there is not right.
I think we'll skip questions on personnel for the want of time. What about quality assurance? What are the clinical quality indicators, safety indicators? How frequently to monitor them? And is audit required for the unit?
Yeah. So clinical quality indicators, certainly the adequacy of dialysis. A good bit of this was discussed yesterday. CKD, MBD parameters, anemia parameters. So when I came here after working in Nadia, I just adapted the sheet which we used to use for monitoring over there, which was designed by Dr. Sheshirgang at Nadia and which I had used there. We adapted it. It has undergone further adaptation. And so we capture all this data at least monthly in all our patients. What are the safety indicators? The increase in the incidence of hepatitis B, hepatitis C would certainly mean that safety is being compromised. So unit should aim for 0 seroconversions. If not 0, it should at least be extremely low. The other would be what was discussed yesterday, episodes of fever with chills on dialysis, episodes of definite catheter-related bloodstream infection would indicate that there is a breakdown in the safety procedures. How frequently to monitor? Clinical quality indicators, monthly at least, and now with the OCMs available, you can actually monitor adequacy at each and every dialysis. One of the most neglected aspects of quality indicators is nutrition. It's difficult. People tend not to do it. Nutrition and quality of life is what often doesn't get filled on our dialysis sheets. So one of the ways I did was when Praveen was to give Praveen that topic as a thesis, so that at least during that time, every patient got an NPCR quality of life assessment. The dietitian was brought to ensure that every patient had an interview with the dietitian at least once a month. She then worked on getting weekly daily dietary recalls, weekly counseling. So that was one way of improving quality. Is an audit required? 100%. And I got some, we've been doing audits for the last 10 or 11 years, and I got some more ideas from listening to what Dr. Atul Moye said about how his unit carries it out. The NABH follows what even many of our, for instance, ADKI guidelines include what is called the Donabedian system. They said you look at structure, process and outcomes. And what our last NABH assesses, I'm not going to look at outcomes because those are market driven. If your outcomes are bad, people won't come for treatment. But we will look at structure and process. And process is perhaps the most important thing to monitor because it's easy, as Dr. Moye said yesterday, to write protocols, but ensuring that they are followed.
So last year we had one entire session on audits. So unfortunately we couldn't get the same faculty this time. So this was restricted to only one question. So what test do I require on the water and machines before I start my dialysis unit, and what test do I require to repeat and how frequently?
Well, again, this is a good chart given in our guidelines of the Indian Society of Nephrology. Now, water must have chemical purity test using atomic absorption spectrometry. And you must go to the lab to find out whether they actually have a working atomic diffraction. Now, the way to find out is, are they able to give 3 digits after the decimal point, at least? If they're not giving that, then they probably are faking the atomic diffraction. So, chemical purity, I would say monthly is required. Microbiological purity, you must do pour plate technique and not just streaking with a wire loop. On regular agar as well as nutrient poor agar, which should be the culture should be followed for at least 1 week, because saprophytes take that much time to grow, and that causes a mess into the water. This is done once in a fortnight simply because by the time you read the first culture and you're ready for the second sample to be taken. pyrogen purity, you need to take highly sensitive LAL test, and that can be done, and that procedure, as well as the vendor from which you can buy, is there in the Indian Journal Nephrology, both the earlier guideline which is adopted by the Government of India, as well as the revision done in 2020. Highly pure means it should be able to detect 0.001 international units of pyrogen.
Just a word on where to take samples from.
For water, you take sample after your treatment at immediately before tank, immediately after tank, and at each dialysis outlet.
And about endotoxin?
Endotoxin.
Okay, endotoxin. Okay.
And if
cultures?
HDF, then you take the HDF infusate fluid and test it, as I said, at 0.01.
I'll add just 2 points to this. Also at the return line,
Yes.
and after, the bicarbonate mixer also should be tested.
Yes.
And bicarbonate mixers need to have built-in or protocolized disinfection protocol. One simple thing that should always be followed: first mix, if you're using 2 dry concentrates, first mix the bicarbonate and then mix the acid concentrate. Because the acid concentrate contains citrate, which is antibacterial, and anyway has a low pH. So it will to some extent prevent bacterial growth, rather than the other way around, where you leave bicarbonate standing in the mixer.
So coming to the documentation, what minimum data should I record for each session, and what logs, that non-clinical logs, do I maintain?
So the minimum data for each patient per session would be, first is his dry weight and incoming weight, and then at the completion the outgoing weight. Also the vitals of the patient should be recorded at the inception, then ideally every 15 minutes, but at least half an hourly, and should be documented. Any what are the machine parameters to be recorded simultaneously would be the blood flow rate, the venous pressure, the arterial pressure, the TMP pressures, the blood flow rate which keeps on fluctuating, so that should be documented at every 30 minutes as well. So also the conductivity and all should be, but a point here is that when the dialysis is to be started, the technician should ask, if you have a dialysis doctor, fine. If you don't have, patient should be asked for history of fall, any dental procedure or any surgery which has been done in previous 48 hours, wherein because the use of heparin would then lead to bleeding. So this should be also asked and documented if possible. And there are other logs apart from the clinical indicators which to be maintained are the water treatment logs, the personnel logs, then the monthly non-clinical parameters, as sir said, the CKD-MBD profile, the anemia profile, cardiac visits, and all that should also be monitored. So listed here.
So what about dialysis guidelines which were published in 2020? I think it was as a supplement. But now it is not available on the website and is being rectified.
It's going to be put. I wrote to Dr. Bansal. Yes. I've sent him the PDFs.
But
and
you can get it. You can get it
Journal
on the
Nephrology.
Indian Journal Nephrology archives. You go, you get it.
Sir, we were not getting it, but it is being corrected,
Okay,
and
I
we
have
are also
brought it here
attaching
if you want
the
to get it.
PDF.
No, I wrote to Bansal. He promised
Individual
to put
chapters are available. And I also prepared from it.
Okay.
Individual chapters are available.
Maybe they have just corrected it.
Actually, in the new guideline 2020, there was a specific chapter added for record keeping and maintenance logs. That was not there in the original guideline.
So after this exhaustive session, we can take questions from the audience or any comments.
Repeated clogging of the filters and all, and then we had to, the hospital didn't want to buy a new bicarbonate mixer which has the one which we had at our center, the one which needs to be integrated to the cap and not at the bottom. So then we had to improvise using a paint mixer to attach it to the cap and then mix on it, so that the precipitation and the further damage to the bicarbonate tank bicarbonate mixer is not happening.
One of the problems with bicarbonate mixers is if the motor is not geared and it runs very fast, then you will get more precipitate foam. It has to be a very slow running geared motor. I got the idea from watching the ice cream mixer. I designed the fan and the system based on that.
I designed the steller also with the same.
Same. Stainless steel has to be the same quality.
Thank you, panelists, for the wonderful session.
Actually, to asking us to be there. Fortunately, I didn't have to ask her a question.